And guys, I think there needs to be more phones in the thing over there, so phones off, put them in there please. Okay, yesterday we went over the mole equation. Okay, so quick review here, okay, that a mole is both a burrowing rodent, okay, and it is a measure of how many particles of a material you may have in a given sample, all right? So Avogadro came up with that idea, okay, and a mole is like a dozen. It doesn't matter what I have a mole of, I always have the same number of particles. If I have a mole of sodium, then I have 6.02 times 10 to the 23 atoms of sodium. If I have a mole of water, I have 6.02 times 10 to the 23 molecules of water. Okay, it applies to everything. It's always going to be that number, just like a dozen is always 12. Doesn't matter whether it's eggs or donuts or apples or whatever. Okay, everyone follow me there? Ringing a bell from yesterday? All right, so yesterday we did type 1 and 2, which only involve using the mole equation. Okay, types 3 and 4 involve the mole equation and Avogadro's number. So there'll be an extra step in these type 3 and 4 questions. Okay, does everybody have number 3 written down? All right, so let's go through how we would solve a type 3 mole equation problem. So how many molecules? All right, so not something that's part of the mole equation, would you agree? Right, like N is number of moles, little m is mass, big M is molar mass. Number of molecules is not in that equation. All right, now, what does this number tell me again?
How many molecules are in one mole?
Right. I mean, technically it's how many particles, because if you were dealing with an element, those particles would be atoms, and if you're dealing with a compound, the particles would be molecules. Okay? But it tells you how many of whatever are in a mole. So if I could calculate how many moles I have, could I use that number and this number to calculate the number of molecules? What would I do with those two numbers mathematically? Multiply them. Okay? Think of it this way. If I told you I had 2 dozen eggs, how many eggs do I have?
24.
How did you do that?
I counted from 0 to 24.
Okay, or you went, there's 12 in a dozen, and you just told me you have 2 dozen, so I multiplied 2 times 12. Well, if I have 2 moles, and I want to calculate the number of molecules, I take the number of moles and I multiply by the number of molecules in a mole. Just like you went 2 times 12, we're going to go 2 times 6.02 times 10 to the 23. Okay, that number works just like 12 does for a dozen.
How do you enter that into a calculator?
I'm going to show you that. We'll get to it. Okay? Yes, I will show you how you enter that in your calculator. Now, what if I gave you the number of molecules and I wanted you to calculate the mass? Then you would divide. Exactly. Okay? It would be like if I said, I have 48 donuts. How many dozen do I have? Okay, how did you do that? Exactly. You took the number you have and divided by how many are in a dozen. You just did the opposite of what I asked you to do before. Okay? That's how type 3 and 4 work. The extra step is you're either multiplying by Avogadro's number to calculate the number of molecules, or you're given the number of molecules and you're dividing by Avogadro's number to get to the number of moles. Okay? That's all you'll ever do with Avogadro's number. You are only ever going to multiply by it or divide by it. That's it.
Question, is there like a, oh shoot, I cannot say anything.
Avogadro?
Yeah, avocado, Avogadro.
Yeah, it counts. Sounds like avocado.
Is that on a calculator? Like, could you just?
I'm going to show you how to punch it into a calculator. We'll get to
Thank
it.
you so much.
Yeah. Okay. So looking at this question here, we're looking for the number of molecules. So I'm going to go hashtag molecules, because that doesn't mean hashtag, it means number. Okay. So number of molecules, question mark, are in 600 grams. What did they just tell me? Little m. That's a 0. 600 grams, okay, of silver nitrate. What's that going to help me get? big M, molar mass. Okay, is it important that I get this formula right?
Yes.
Yeah. Okay, so silver nitrate, NO3, that's a -1, that's a +1, sweet, already done. Okay, I don't have to do anything with it. Okay, now I just have to put in my numbers here. So 107.87. Okay, 107.87. Okay, only one. How many nitrogens?
1.
1. Okay, so plus 14.01 plus how many oxygens?
3.
Okay, so 16 times 3. Sorry, I should have fired that up earlier. It takes a while to load.
It's 48. 16 times.
Yeah, 16 times 3 is 48, yeah. Okay, so 107.87 plus 14.01 plus 48, which is 16 times 3. Okay, 169.88. What were the units for that? Grams per mole. All right, so we got that in grams per mole. Okay, how does that help me get the number of molecules? The answer is it doesn't. It helps me get number of moles. That can help me get the number of molecules. Okay, I have little m, I have big M. The only thing I can calculate is N. Okay, now, if ever on like a quiz or a test, you have a question like this and you've written it down, you're like, I don't know how to get the number of molecules, but you notice you can calculate N, do it. You're getting part marks for method. Even if you don't get past that because you can't remember what to do with it, you're still getting marks for that step. It's way better than leaving it blank. Okay? The worst thing you can do on a question is leave it blank. I mean, you get 1 mark for writing down the givens, so you might as well write that down. Okay? All right, so in this question here, you'd get 1 mark for the givens, and you would get 1 mark for the mole equation / plugging in the numbers here, so that would be 600 grams divided by 169.88 grams per mole. Okay, the grams are going to cancel, and I'll be left with the right units, moles. Okay, so 600 divided by 169.88 is 3.53 moles. Now, something that's really important here. I'm only writing 3.53 on the board, but I'm keeping all the decimals in my calculator. Okay, that's really important for the purposes of accuracy and something we'll probably talk about in physics called significant digits. Okay, so we want to get in the practice or the habit of always keeping all the numbers, okay, all the decimal places in the calculator. All right, now I have the number of moles. I have N. So I have number of moles and I have the number of particles, in this case molecules, in a mole. What do I do with those two numbers to get the number of molecules? Multiply them. Okay, so N times Avogadro's number, okay, will give me the number of molecules. Okay, so that's going to mean taking the 3.53 with all the decimals in it, okay, and multiplying it by 6.02 times 10 to the 23. Okay, let's talk about how we punch that into our calculator. Okay, depending on the type of calculator you have, okay, you are either going to have a button that looks like this, okay, it says EXP, right, or you're going to have a button that looks like this, EE. Okay, pressing either one of those buttons will usually put something on the screen that looks like this. Times 10 or a capital E, one or the other, okay, depending on the calculator you have. Unless you have a graphing calculator, which you're going to watch me on the board do this, because what I do is exactly what you'll have to do. So if you have a TI infinitely amount of numbers, whatever it is, 84, 5, 250, okay, I don't know what they're on. I think they stopped using numbers and went to words now, right? Inspire or something like that. Python. Okay, yeah, they're going to all sorts of weird things. Okay, if you got the Texas Instruments, follow what I do. Okay, how many people have the EXP button on their calculator? If you have my calculators, you have that button. Okay, if you have, how many people have this one, the EE? Okay, now here's what you're going to do. Okay, if you have either one of these buttons, right, what you're going to do is you're going to put a bracket and you're going to go 6.02, and then you're going to press either, whichever button you have, okay, press that, okay, and either you'll get this up in the corner, okay, times 10, or you'll get an E here, one or the other, okay, and then you're going to put 23. You're just going to punch in 23. It'll either go up here or it'll be beside it, okay? Everybody follow me there? Then close the bracket. Then you've entered Avogadro's number. If you have the graphing calculator, follow what I do here. Okay, the graphing calculator has the double E button, but it's the second function of the comma. Okay, so here's what we're going to do to enter Avogadro's number. First, I want that number there. That's n, so I'm just going to go and grab that. And then I'm going to multiply by, and Avogadro's number always has to be enclosed in brackets. Always. Okay, so put a bracket, and then I go 6.02. I hit the second function button, and then you see I get the up arrow on the screen there, and then I hit the comma, and that will give me, it says double E, for whatever reason, when you hit it, you only get one E. Okay, but you're good, okay, one E. And then you just go 23. And then you close the bracket.
Okay, I don't have that.
Okay, I'll come have a look at yours in a sec.
Right.
Okay, so that's now the calculation that we have right here, okay? Taking our number of moles and multiplying it by Avogadro's number, all right? So now that I've got that in there, okay, I can just hit enter, and I get that. Okay, does that number should make sense, right? I had 3.5 moles, so the number I got is significantly larger than Avogadro's number. Okay, so that number makes sense then. That's the number of molecules of silver nitrate in 600 grams. I would write it on my paper like this. Okay, I would go 2.13 because I'm only keeping 2 decimal places. Okay, and the 6 would round up to 2. Okay, so 2.13 times 10 to the 24, because that's what it says on the screen. Okay, times 10 to the E24, so times 10 to the 24. Okay, what are my units? Molecules. Yeah. Okay, and that would be my answer. Okay, any other questions on the type 3? All right. This is the last type, type 4. In type 4, I give you the number of molecules, and I ask for mass. Okay? So, it's basically what we just did, but by completely reversing the order. Okay? We work backwards. Do what we just did, but backwards. Okay, what's the first thing we do? Write down the givens, okay? Anytime we're doing any kind of problem solving, the first thing to do is write down the givens. What is the mass? Okay, so I know I'm looking for little m, okay? Of 1.54 times 10 to the 25. Is that more than 1 mole?
Yes.
Yeah, we just covered that, right? It's like 90 to 100 times, probably somewhere in there, right? If 1 mole is 10 to the 23, that's 10 to the 25, that's 2 powers of 10, that's 100, right? Okay, I mean, it's maybe not exactly 100 times bigger, but it's a lot bigger, okay? So I can put in that I know the number of molecules. Okay, 1.54 times 10 to the 25. Of diphosphorus tetraiodide. What can that help me get? Big M. All right, so diphosphorus, P2, tetraiodide, I4. Should I reduce that?
No.
No, because it's molecular. Am I enough of a jerk to do that on the test? Absolutely. Okay, so phosphorus, we got 30.97. Okay, and there are two of them, plus the iodine's 126.9. Okay, 126.9. Okay, times 4. Okay, so that stuff has a molar mass of 569.54 grams per mole. Okay, if I want to find mass, I need number of moles. Okay, how can I get it?
1.54 times 10 to the 25 divided by 569.54.
Not quite. I am going to divide the 1.54 times 10 to the 25 by something. What am I going to divide it by, Hen?
I was just saying, can't you just times n by like the molar mass? The mass by itself?
I don't have n though.
Oh,
I got to find n first. That's my next step. I'll be doing that as the last step. Yes, multiplying n by big M. Definitely that'll be my last step.
Divide the amount of molecules by Agrabato's number.
Right. Okay, I'm going to take the number of molecules, the number of particles here, and I'm going to divide by Avogadro's number. Okay, because this is the number of things I have, this is the number in 1 mole. Okay, if I divide those numbers, I get the number of moles. Okay, look at it like this, guys. Okay, Avogadro's number. Okay, we never put units beside it, but its units are essentially, in this case, it would be molecules per mole. Okay, that's really what Avogadro's number is. It's the number of particles in a mole. So in this case, we could say it's molecules per mole. I have the number of molecules. If I divide molecules by molecules per mole, what will I be left with? Moles. Okay, cool. That's what I'm looking for. Okay, so to calculate the number of moles, I'm going to take the number of molecules, okay, and divide by Avogadro's number. The opposite of what we did on the last question. Okay, so I'm going to take 1.54 times 10 to the 25, and I'm going to divide it by 6.02 times 10 to the 23. Remember that this is molecules, and this is molecules per mole. Okay, now, how do I punch that mess into my calculator? Like this. Everything's got to be bracketed, right? So the 1.54 gets its own set of brackets. Okay, so we go bracket 1.54 E25 or times 10 to the 25 or whatever button you have on your calculator. And then I simply divide that by, in brackets, Avogadro's number, 6.02 E23. Okay, that's taking the number of molecules and dividing by molecules per mole, and it's going to leave me with moles. Okay, 25.58 moles. Okay, am I done?
No.
No. I now have the number of moles and the molar mass. Can I find mass?
Yes.
Yes. Okay, so now I'm going to have to take the mole equation and manipulate it so it solves for little m, mass. Okay, so what do I do with big M?
Multiply it.
Multiply it over to this side. Okay, oh, sorry, I forgot to tell you where all the marks are going. Okay, so 1 mark for givens. Okay, 1 mark for this step where you calculate the number of moles. 1 mark for the mole equation, okay, and manipulation. Okay, so that'll be In this case, okay, we're gonna have big M, so that was 569.54 times the number of moles, which was 25.58. Okay, so basically, when we're done that first part, it becomes just a type 2 question. Okay, we're solving for mass. All right, so we take that number and we multiply it by that number. Okay, now we said we had a lot. Okay, we have 14,569.63 grams. Point 60. That's 14.5 kilos of that stuff. Okay, it's 32 pounds of it. That's a lot. Okay, it's a lot of diphosphorus tetraiodide. Okay. All right, you've now seen one example of each of the 4 types of mole equation questions. Those are the only 4 ways I can ask you a mole equation question. There's no tricks. Those are the 4 ways. Okay, on your unit exam, should you expect to see all 4?
Yes.
Yeah. All right. Any questions on that last one? Okay, so the last one is a 4 or 5 mark question. It's 1, 2, 3, yeah. Sometimes I give an extra mark for the plugging of numbers, so 4 or 5. It's the longest one, okay? It has the most steps. Okay? All right, ready to try some on your own?
Is there any way to remember like big M and small m and N, because they all kind of start with M?
You just have to memorize it, right? You have to know N is number of moles. M is mass, grams are small. So lowercase m is mass, grams are small. Big M is big numbers from the big table. I don't know. Whatever trick is going to work for you, that's what works for me.
Okay.
Okay. Come on. Okay, here are another 4. Okay, said we'd go through 4 a day. All right, so here are your 4 examples for today, okay, of mole equation questions. There's one of each type here. I'm pretty sure they actually go in order. Okay. Yes, they do. Right, can you refer back to the examples you have in your notes already? Yes. Okay. All right, I'll give you a few minutes and we'll get... Okay, so for number 1 here, guys, okay, we're looking for how many moles. So we're looking for what part of the mole equation?
N.
N. Okay, so we're looking for N, okay, and the material we're dealing with is carbon dioxide, okay, so we can get big M with that, CO2, that's going to be 14.01, okay, plus 16 times 2, which should be 44.01, right? No, 46.01. Is it 44? I should not try to do mental math, especially before my coffee. Okay, grams per mole. All right, and they also tell us that we have 150 grams, which is little m. All right, so again, you get 1 mark for your givens. Then we have to use this equation, which I know right now seems silly to give you a mark for just writing down an equation that's already on your formula sheet, but by the end of the semester, and when we've done physics and global systems, you will have used every formula on the formula sheet. Now then it's worth a mark to choose the right formula, right? Okay, so N equals little m over big M. Do I have to manipulate it for this question?
No.
No, it's already set up to solve for number of moles. That's what the question wants. Okay, 150 grams, okay, divided by 44.01 grams per mole. Okay, when I do that calculation, the grams are going to cancel. Going to leave me with moles. 150 divided by 44.01 we're looking at 3.41 moles. Okay, remember, final answer, 2 decimal places is fine. Okay, Keegan, question?
I was gonna ask if we round, but you said 2 decimal places.
Yes, and I did round. I rounded to 2 decimal places. It was 3.408, I believe. Okay, so I rounded the 0 to a 1 and kept that. All right, any other questions on number 1?
That's really interesting. I found a different answer.
Okay, 150 divided by 44.01.
42.
Well, 16 times 2 is 32, right?
Wait, so.
You know what, that's got, I don't feel like that's right. I was right, it was
Number
46.
for Carbon isn't.
Oh, it's 12.01, that's okay, that's why, I was like, I'm sure that's 46, yeah, it's because Codere can't remember that carbon is 12.01. Now it's right, or it was always right. Something like that.
It's right now.
Yeah, it's too early. I have not had enough coffee. Okay.
Caffeine.
Yes, caffeine is good.
Very.
Yeah, whoever decided these berries have this bitter seed in the middle, I should cook that in water and drink it. They were brilliant. Brilliant. Okay. Okay, and how many people have done number 2? Okay, all right, let's have a look at number 2. All right, so number 2, type 2 question. We're looking for the mass. It says, what is the mass? So we're looking for little m, okay? And they tell us that we have 26.5 moles. That's actually quite a bit. Okay, of cobalt 2 bromide. What will that help me get?
Big M.
Big M, right. All right, so cobalt 2 bromide, so that's the 2 plus cobalt. Bromine's always -1, so we're looking at COBr2. Okay, cobalt 58.93. Okay, there's only 1 cobalt, so I don't need to multiply that by anything, but I do need to add it to 2 bromines, so that'll be 79.9 times 2. 58.93 plus 79.9 times 2. All right, so 218.73. Okay, grams per mole. All right, so I'd have 1 mark here. Okay, I need to use the mole equation. N equals little m over big M. Okay, and I need to manipulate because I'm solving for little m. So what do I do with big M? Multiply it over to the other side. Okay, so multiply both sides by big M cancels there, big M comes over here, okay, and then we're looking at 28.73 times,
218.
sorry, 218. Missed that number, man. Okay, times 26.5. All right, times 26.5. Okay, so we are looking at almost 6 kilograms, okay, of that stuff. 5,796.35. What are my units? Grams, right. Okay, for that one. Questions on that? Okay, so that would be, hey, you get a mark here, you get a mark for your using the mole equation, you'd get a mark here. Okay, so you'd be looking at 4 marks for that one. Okay? Questions there? All right, I'll give you a little bit more time for 3 and 4. I'll put them back up on the board. Okay, and then we'll go through them. Emily?
So for like the final answer, if we're like 1 decimal point off,
There really shouldn't be a reason to be a decimal point off.
like if it was like 0.34 instead of 0.35, would you take the point off?
I probably would, because it would mean that either you didn't round it right or you didn't carry all your decimals all the way through, which are things we have to do. I know that seems picky, and it is. All right, so on number 3 here, the number of molecules is what we are looking for. Hey, does that mean we're going to need Avogadro's number?
Yes.
Yes, as soon as you see the word molecules, Avogadro's number is in play. There's only 2 things you're going to do with it, multiply and divide. In this one, which one are you going to do? Multiply. If you're going for the number of molecules, is that a big number? Okay, do numbers get bigger when you multiply?
Yes.
Yes, okay. So if I take the number of moles and multiply by Avogadro's number, I should get a big number. That's what I'm looking for. Okay, when we're going the other way, we're trying to get number of moles. That's a small number. I get smaller numbers by dividing. Okay, if you need a trick to remember it, okay, that can work. All right, so we have material, sodium sulfide, so that'll help me get big M. Sodium with sulfur, that's a -2, that's a +1, so we'll be looking at Na2S. All right, and that's going to be 22.99 times 2 plus 32.07 for the sulfur. Okay, so 22.99 times 2 plus 32.07 gives us 78.05 grams per mole. And they also tell me I have 29 grams of this stuff. That's not very much. Okay, so I have little m, 29 grams. Okay, so I'd get 1 mark there. If I want to find the number of molecules, I need the number of moles. Okay, so N is a question mark here, right? N can be calculated by dividing little m by big M, and I have both of those numbers, right? So I can definitely do that operation right now. That'll be 29 grams divided by 78.05. Do I have more or less than 1 mole? Less. It's okay if I get a decimal here for N. It absolutely is. Okay. All right, 29 divided by 78.05. Okay, so we got 0.37 moles. I'm going to keep all those decimals in my calculator. 0.37 moles. All right, now that I have N, how can I use it to find the number of molecules?
Multiply by Avogadro's.
Multiply by Avogadro's number. All right, so number of molecules equals N times Av's number. Okay, so that's going to be 0.37 with all the decimals from my calculator, multiplied by 6.02 times 10 to the 23. Okay, remember that this is moles and this is molecules per mole. When I multiply those together, what happens to the moles? They go away and I'm left with molecules.
When we're writing it out,
Mhm.
instead of writing out the entirety of Avogadro's number, can we just put AV?
No. You may not. You must show your work. Okay? All right. So we got that number, and we are multiplying it by Avogadro's number. All right, so we are looking at a number that is smaller than Avogadro's number, which makes sense. We had less than a mole. Okay, we're looking at 2.24 times 10 to the 23. Okay, so you'd have a mark for givens, a mark for this step, a mark for this step, and a mark for your answer. 4-mark question. Okay, now, just so you don't think I'm being a jerk here about showing work, here's why I demand that you show work. There are tons of opportunities to make typing errors on your calculator when doing mole equation calculations, and it happens all the time. If you show all of your work, and all of your work is correct, and all you get wrong is the answer because you can't type, okay, you only lose 1 mark for not being able to type good. Okay, that's definitely better than writing down a number that's wrong, showing no work, and getting 0 because you couldn't type good. Okay? Now, I only say that because I've seen it happen, and I've seen it happen like tragically. Okay? I had a kid, what was it now, like 16, 17 years ago. Okay, he refused to show his work. Absolutely refused. Now, he was a smart kid. Okay, he didn't make very many mistakes. On the final exam for physics, we reset the calculators, which changes them from degree mode to radian mode. So anything that involves using sine, cos, or tan is calculated differently. Close to half the questions on the test involved using sine, cos, and tan. He didn't show any of his work, used the wrong trigonometric ratios, and got all of those questions wrong. Because all he wrote down was a number, and the number was wrong. Okay? He probably should have got 85 or 90 on the final exam. Okay? Instead, he got a number in the low 60s. Right? Show your work. Moral of the story, show your work. Okay? Because little things can happen. All you have to do is type one number wrong. And then I look at your answer and I'm like, it's not the right number. And you have no proof. If you have the wrong number but all this correct proof, then I go, oh, that's too bad. They just didn't type very well. I'd rather only lose 1 mark for that than all 4 marks for not showing anything. So always, always show your work. Okay? All right, how many people have done number 4? Okay, anybody want a little bit more time on 4? Okay, I'll give you another couple minutes here. All right, let's have a look at number 4 here, guys. So in this one, they're asking for the mass. So we're looking for little m, okay? And they tell me the number of molecules. Okay, number of molecules is going to be 7.2 times 10 to the 23. Is that more or less than a mole? Just a tiny bit more, right? If 1 mole is 6.02 times 10 to the 23, this is 7.2 times 10 to the 23. It's just a little bit more than a mole. Okay? All right. And we are looking at the material being diphosphorus pentaoxide. So that will be helping us get big M. P2O5, so that's going to be 30.97 times 2 plus 16 times 5. Okay, so 141.94 grams per mole. Okay, so we get 1 mark for our givens. Now, if I'm going to calculate little m, I need the number of moles. How do I get it?
Number of molecules divided by Avogadro's number.
Right, I take the number of molecules and I divide by Avogadro's number. Okay, what I'm essentially looking for here is if I asked you, I have 36 donuts, how many dozen do I have? You would go 36 divided by 12. Okay, in this case here, that's exactly what we're doing, but we're doing it with moles. Okay, so I'm taking the 7.2 times 10 to the 23, I'm dividing it by Avogadro's number because that's the number in a mole, and I'm going to get the number of moles. Okay, so that's going to be the number of molecules, okay, divided by Av's number. Okay, when we plug that in, that's going to be 7.2 times 10 to the 23 divided by 6.02 times 10 to the 23. Now, just a minute ago, as soon as I wrote that number, I said, is that more or less than a mole? Why do I ask you that?
So you can see if your calculations are wrong.
Exactly. It gives you an idea, okay? These are the things I ask myself when I'm doing these questions so that as I'm going through it, I can look at my number and go, ooh, I must have done something wrong in my calculator. And I can go back and check, because that happens, okay? It's really easy to type things in wrong. Okay, so I asked myself, is that more or less than a mole? It's a little bit more than a mole, so I know what kind of answer I should expect from my calculator when I do this operation. In fact, if I was really with it in terms of my math skills, I wouldn't even bother putting in the 23s. Why not? Yeah, because they're the same. They essentially cancel, but we'll put it all in just for the sake of doing it. Okay, all right. 1.196. All right, that kind of fits with what I asked myself. I said, be a little tiny bit more than a mole. That's a little tiny bit more than a mole. Okay, so that kind of fits. All right, now that I've got that number, okay, and that, by the way, would be your second mark, okay, now I can look at solving for mass. So now I would go n equals little m over big M, and I would manipulate it by multiplying both sides by big M, and I'd get a mark for that. Okay, and then I would go 141.94, my molar mass, okay, that's in grams per mole, and I would multiply that by 1.196 moles, okay? The moles will cancel, and I'll be left with grams, okay? And I'm gonna keep all the numbers in my calculator there. So take the 141, okay, and multiply it by that number. Okay, so I have 169.76 grams. Okay, so mark for that, I think that's 5 marks. Yep. Okay, questions there? Pretty good with that? All right, what do we got for timer? Okay, I'm gonna give you about a 3-minute break, and then I'm gonna put some on the board for you to just practice with. All right, so for D here, we have 100 grams of sodium chloride. So for that one, we have mass, so we have little m, 100 grams. We have the material, okay, it's sodium chloride, so NaCl, it's gonna be 22.99 plus 35.45. And so we're looking at 58.44 grams per mole. And we're looking for the number of moles. Okay, so N equals little m over big M. We have both of those numbers, so simply 100 grams divided by 58.44 grams per mole. Grams are going to cancel, and we're going to be left with 0.584. So 0.58 would be as far as, sorry, that's not what it's going to come out to. It's going to be like 1.8, right, or 1.9. How about I just punch it in instead of guesstimating? 1.7, okay. 1.71, what are my units? Moles. Okay, so that would only be a 3-mark one. All right, questions there? All right, what type was that? Type 1. Yeah, calculating number of moles is type 1. Okay, for E, we got 26 grams of nitrogen. All right, so in that one there, we know, okay, in that one we know the mass, 26.0 grams, and we know the material is nitrogen gas. That's going to have a molar mass of 28.02 grams per mole. Why?
Because nitrogen compound by,
Molecule?
no, the nitrogen as an element only exists in N2.
Right, as a molecule of 2 nitrogen atoms, okay? All those molar masses are based on single atom masses, okay? So if I have a molecule of N2, its molar mass is 28.02. Okay, so I am looking for the number of moles, okay? N equals, again, little m over big M, so I don't have to do any manipulating, it's just 26 divided by 28.02, so we're gonna have like 0.9 something, okay? 26 divided by 28.02. All right, so 0.93 moles. Okay, everyone okay with that? How many people have done B and D? Okay, how many people have done B? All right, let's have a look at B, and I'll give you a couple more minutes here. Okay, so on B, we have 4.2 moles of carbon dioxide molecules. So in that one, we're given N, 4.2 moles, and we're told that it's carbon dioxide, CO2, Okay, so that's going to be 12.01, not like earlier today. Okay, plus 16 times 2 for 44.01 grams per mole. Doing it right, and I've had some coffee since we did that one, and I'm more alert now. Okay, we are looking for the mass. Okay, so in this question here, we do have to manipulate the mole equation in the only way we ever have to manipulate it, by moving m, big M, over to this side so we can solve for little m. Okay, so when we plug in our numbers there, that's going to be 44.01 grams per mole, okay, multiplied by 4.2 moles. Okay, when we do that, the moles are going to cancel, and we'll be left with grams. Okay, so 44.01 times 4.2, and we got 184.84. What are my units? Grams. All right, I'll give you a couple more minutes to get D done there, guys, if you don't already have it done. All right, so on D here, guys, we have 36.8 moles of magnesium chloride. So we know N, 36.8 moles. Okay, and we know that it's magnesium chloride, MgCl2. So that's going to be 24.31 plus 35.45 times 2. Okay, so 93.21 grams per mole for the molar mass. Okay, we're looking for little m, right? Which means we're going to have to manipulate, again, in the only way we ever have to manipulate that formula. Okay, multiply both sides by big M. Okay, now I had a question. Coderre, do I need to show this? No. Okay, you don't have to show that. As long as you show me the initial equation, n equals little m over big M, okay, and then your final manipulation, that's good. That's showing your work. You don't actually literally have to cross things out if you don't want to. If you totally want to, because I do all the time, you go right ahead. Okay, that's also.
Is 95?
Yeah.
Yeah, it is.
Yeah, you put 34.
34.45.
Oh. Instead of 35.45. Okay, good catch. I hit the wrong button. 24.31 plus 35.45. Okay, 95.21. You are absolutely right. Okay, 95. All right. Now we need to do the multiplication here. So take that 95.21. Okay, grams per mole, and multiply it by 36.8 moles. Okay, and okay, we'll have times 36.8. Okay, 3,503.73. What are my units? Grams. Okay. All right, questions on how those work? Okay, good job today, guys. We'll go over another 4 tomorrow. Quiz on Friday on moles. You have lots of moly questions to work on.